Alright guys, welcome to Math Academy. Mr. Grady's here, and let's talk about what we're going to be learning, why we're learning it, and how you'll know if you successfully learned what you needed to. So today we're going to actually go through and learn about Pythagorean Theorem. So our goal for today is that you'll be able to use the Pythagorean Theorem to solve for missing side lengths in a right triangle. So why are we learning this? We've already learned about squares and square roots. We've done that. We've quizzed over that. We're good there. All we're doing now is we're going to take what we've already learned about that and apply it to the situations above, which are right triangles. And then how will you know if you successfully learned what you need to? When you are given two side lengths of a right triangle, if you can determine the length of the missing side length, so one will not be there, and you're going to use Pythagorean theorem to do that, then you're going to be successful. Now, before we start here, you are going to need your Cornell notes out from the previous week. So if you could take a second and get our notes out that we talked about Pythagorean theorem on, that would be awesome. So I'm going to give you just a second, get your Cornell notes out that had Pythagorean theorem on them. All right, now before we get started, I do have one quick question for you. So here's the question. Why couldn't the bicycle stand up? Why couldn't the bicycle stand up? It was too tired. Get it? Tires, two tires. Okay, the dad jokes are just getting worse and worse, aren't they? But that one's funny. I know you think it's funny. All right, so with that said, after our awesome dad joke, as you remember, we've covered Pythagorean theorem in our notes. What I want you to do real fast is, starting with partner number 1, you're going to read everything that we wrote down about Pythagorean theorem to your partner. Then partner number 2, you're going to read everything else that we wrote down about Pythagorean theorem. So you're both reading the same information twice. So you're going to say it once and listen to it once. So partner number 1 start, you're going to read all the information. Then partner number 2 follow up, you read all the information on Pythagorean theorem. Ready, go. All right, so now that you've reviewed a little bit on Pythagorean theorem, you've said it once, you've heard it once from your partner, let's go ahead and get started. If your teacher has not passed out our guided notes for today in our practice, I'm going to give them a second to do that. So we'll go just about 20 seconds here, let your teacher get everything passed out to you. Okay, so the top of our notes have some blanks we're going to fill in. So as we read through these together, you're going to follow along and we're going to fill these blanks in, and it's going to tell us and remind us information about Pythagorean theorem. So the first sentence says the blank for the Pythagorean theorem is blank. Okay, so our first sentence is going to look like this. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. And we talked about that in our notes the other day, and you just read that to your partner. So one more time, everybody turn to your partner and tell your partner the formula for Pythagorean theorem. Go. All right, let's look at the second sentence. So it says Pythagorean theorem can only be used on blank blank. This is the type of triangle it can be used on. So Pythagorean theorem can only be used on right triangles. Now remember, to be a right triangle, it has to have a 90-degree angle somewhere in that triangle. So remember, a 90-degree angle is like a corner or like an L. That makes our right angle 90-degree angle. All right, let's look at our third sentence. So it says blank and blank are always the blank. So that's going to say A and B are always the legs. Now, hopefully you've started to notice this. Every time that I refer to the formula, our letters A, B, and C are lowercase, and that's for a reason. That's the way that we have to write them. So make sure you're writing all your letters lowercase. And again, A and B are always the legs. Everybody say legs. All right, let's go to the last sentence. So several blanks here. So we are going to fill them in with C, side C, again lowercase, is always the hypotenuse. Everybody say hypotenuse. One more time, hypotenuse. We had this word in our notes that we talked about the other day. So the hypotenuse is always the longest side of our triangle. But the important thing to remember is that that side is opposite of the right angle. Everybody say opposite the right angle. One more time, say opposite the right angle. Okay, so I'm going to give you just a few more seconds to jot this down in case you needed to fill in a blank, and then we're going to go ahead and get started and look at how we're actually going to use the Pythagorean theorem. All right, so our first section of our actual notes say that we're going to be labeling the blank, blank, and blank. So there's really three parts to our triangle that we have to get down and know and be able to label. So those are, first of all, the right angle. So we're going to label the right angle. The next thing we're going to label is the hypotenuse, which is that weird word, so everybody say hypotenuse. And then the last thing we're going to label are the legs on our triangle. So I'll give you a second. Again, we're writing down right angle, hypotenuse, and legs. So let's go ahead and talk about what this really means. So if we talk about our right triangle, or we think about a right triangle, we already said that our right angle is the corner or the L shape of our triangle. So when a triangle is just basically like we would see it, up and down, it's pretty easy to pick out that our corner in this triangle would be this bottom left portion of the triangle. So our right angle, our 90 degrees in this triangle, is the bottom left corner. So we're going to go ahead and we're going to label that. Now we know this, or we know how to label this, is just a box. So we're going to put a box here, and remember, this represents our 90-degree angle. So go ahead and do that. The next part we're going to label is the hypotenuse. Now remember what we wrote up above. We said the hypotenuse is the longest side that's opposite of the right angle. So if you can locate the right angle, then it's very easy to find the hypotenuse. Just remember that the hypotenuse is opposite of our right angle. So if I draw a line like I did, an arrow straight pointing opposite, I run into the hypotenuse. So you're going to write and you're going to label that our diagonal is the hypotenuse. Okay, now we've talked about this already a couple times. The hypotenuse is always, always, always letter C. So go ahead and label that. So if we know the right angle is in the corner and the hypotenuse is our diagonal longest side that's opposite of the right angle, that just leaves our other two parts of our triangle as legs. So let's go ahead and label that. So we have our base of the triangle is a leg, and then we have the height of our triangle is also a leg. Now, the cool thing about the legs is they could be A or B. It's interchangeable, and we put that in our Cornell notes. So when we label this, you're going to write that our height, or our other leg that's going up, is A/B, because it could be either side, and we'll talk about what that means here in a second. And the base, that leg, could also be A or B. Okay, so we just labeled the parts of our triangle. We want to be able to identify them. Let's go over to our next triangle. So the next triangle is kind of rotated a little bit. So we're again looking for the corner that's 90 degrees. So if I go through my three corners here of my triangle, I can see that this top corner is actually my 90-degree angle because it makes that perfect corner. So I'm going to take my writing utensil here, and I'm going to make a box to represent our 90-degree angle. Then remember to label my hypotenuse. It's just opposite of my 90-degree angle. So I'm going to label the longest side the hypotenuse. And again, that's always, always, always letter C. That's the side that has to be letter C. And again, that leaves our other two sides as legs. So we have one leg, and again, that's A or B. And we have another leg, that could be A or B. Okay, so what I want you to do right now is I want you to do the last two. So I want you to label the 90-degree angle, draw your arrow pointing across to the opposite side, that's the hypotenuse, label that as the hypotenuse C, and then label our two legs A and B. So I'll give you just a second to go ahead and label those. Go. All right, so since you've had a second now, let's go ahead and let's check our work. So on our last two triangles, they should have been labeled like this. So we had the hypotenuse, that was this side of our triangle with our 90-degree angle. Again, it's opposite. We have a leg AB and a leg AB here. And then finally on our smallest triangle, the 90-degree angle, opposite of that is the hypotenuse, and then we have our two legs A and B. So looking at the next section of our work, we're going to now actually do a few problems. So before we start, as you can see, there's a blank in this section that says solving for blank. Now, what I want you to do is discuss this with your table partner and see, based on the numbers that I've given you, see if you can figure out what side we'll be solving for in this section. So I'm going to give you about 10 or 15 seconds, discuss it with your table partner. Which side do you think we'll be solving for? Go. So hopefully you guys were able to determine that I gave you both of the legs in this section, which means we're going to be solving for the hypotenuse. So go ahead and write this down, solving for the hypotenuse. Again, the hypotenuse is always C. Turn to your partner and say hypotenuse. So the hypotenuse is always side C. So as we go through starting to solve this, the first thing that I need you to remember to write down is our equation. So remember that our equation, or our formula that we're going to is a squared plus b squared equals c squared. Now up above, we practiced labeling things. Over in our first example, I've given you our 90-degree angle, which means, again, opposite of that 90-degree angle is the hypotenuse, or side C. So the first thing I'd like for you to do is draw your arrow pointing opposite and remind us that this side that we're trying to figure out is C. C is missing. Now remember, if C is missing, that means A and B are given to us. Now, it doesn't matter if we put A next to 4 or if we put A next to 8. A and B are interchangeable. So for this problem, let's all do it the same. And we're going to label 4 as A, and we're going to label 8 as B. So from here, all we're doing is substituting information into our formula. So if we look over to our formula, it starts with a squared, and we know that a, over in our triangle, is 4. So we're going to take this 4 over, and where a is in our formula, we're going to substitute a 4 in. So mine's going to look like this: 4 squared plus, so now we know that we labeled the side that's 8 as b, so it's going to say plus 8 squared. And that's going to equal c squared. So again, we have to keep these squared. Our next step is to start to work this out. So you're going to take our squared, and we're going to actually square them. So our first step is to do 4 squared. So remember, we talked about this before. That's 4 times 4. So everybody help me out. What is 4 times 4? So I have 16 plus, and again, we're going to square are 8. So again, everybody help me out. What's 8 times 8? And that gives us 64. And again, that's going to equal c squared. Our next step is just to combine like terms. So we're going to combine our 16 and our 64. So we're going to add 16 plus 64. I'm going to give you a second. Go ahead and do that. And 16 plus 64 gives me 80. So I'm at 80 equals c squared. So we're getting closer and closer to getting c by itself, but we're not quite there. Now remember what we've talked about before. Normally the last step of an equation is division, because we're usually given a coefficient with multiplication. In this case, though, we're given c squared. Now we've talked about this before. I want to see if you can remember. So turn to your table partner and see if you can remember and tell them, what is the inverse operation of squared? What's the inverse of squared? So hopefully you remembered the inverse operation of squared is square root. So in Pythagorean theorem, our last step is always going to be to square root whatever number we are left with that's by itself, our constant. So our final step is going to be to square root 80. And that's going to give us what c is. Now we know from previous experience that 80 is not a perfect square, so this answer is going to be a decimal. I've given you back your calculators today to use on this, so go ahead and type this into your calculator. Remember, it's second button up at the top, and then the x squared button, which is further down. It's like 5 buttons below the second button. 80, hit enter, and see what you get. And we're going to round our answer to the tenths place, because that's what we've been practicing. So I'm going to give you a second to get that answer. All right, so our answer for this one should look like this. Now, I want you to turn to your table partner, and I want you to say that decimal the correct way. So without saying the word point, say it to your partner. Ready, go. So hopefully you said 8 and 9 tenths. So what that's telling us is the length of this side C over here is 8 and 9 tenths. Okay, let's try one more, and then you're going to have some practice. All right, so the second problem that I've given you, and it's the one to the right, looks like this. So again, in order to start, we're going to take our writing utensil and we're going to draw our arrow coming from our 90 degree. And again, that tells us that C is missing. Again, it doesn't matter which other of the legs are A and B. So I'm going to put A next to 3, and I'm going to put B next to 7. And again, we're just substituting those values into our formula where they go. So for A squared, we know that's 3. So it's going to say 3 squared. And again, we're getting that from where we labeled as A in our triangle. For B, we're putting 7, because 7 was the length of the side, the leg that we labeled as B. And then again, we're missing C, so that's C squared. So just like last time, we're going to just start by squaring. So you guys help me out here. So you guys are going to tell me, everybody, what is 3 squared? So again, that's 3 times 3, which gives us 9. Plus, again, I need you guys to help me. What's 7 squared? One more time, what's 7 squared? So it should have been 49, and that gives us C squared. So then we combine our like terms. So we're going to combine our constants and do 9 plus 49. 909 plus 49 gives me 58. And like our previous problem, we already have talked about the perfect squares, and we know 58 is not a perfect square. So our final step, remember, is the inverse of squared, which is square root. And when we square root 58, we know that we are not going to get a whole number, because again, it's not a perfect square. So I'm going to give you a second to get your answer for the square root of 58 rounded to the tens place. All right, I want you to turn to your table partner, and saying our decimal correctly, I want you to tell them what our answer should be. So if we did our square root correctly, our answer should be 7 and 6 tenths for C. Okay, so again, that means that our side length of our triangle that's labeled as C is 7 and 6 tenths. So the next thing you're going to do is you have 2 more problems, and you're going to practice with these 2 problems, and we'll go through and we will check your work here in just a minute. Okay, go ahead and start your practice. All right, so now that you've had some time to work through these two problems, let's go ahead and check how we did. So this was the first triangle that you had to find the missing side of C. So let's just go through real fast, checking your work. So you should have labeled 24 or 32. Now remember, you could have these switched and could say A here and B here, and you would still be fine. All that would be switched was the numbers would be in different places. But when you square these two numbers, you get 576 and 1024. Add those together to get 1,600, square root 1,600, and that gives you 40. So we know that 40 is the length of side C. Let's look at our second one. Again, C was missing. It's opposite of our right angle. So if you put 28 as B, then it would be over in the spot where 21 is. But other than that, we should have these two numbers. 28 squared gives us 784. 21 squared gives us 441. We combine our like terms to get 1,225. Again, the inverse of squared is square root, so that's our last step, and we get 35 as our answer for C. All right, so let's look at the back of our paper. And on the back, again, it says solving for a blank. Now, it's missing a word, and you have to figure out what it is. So like last time, I want you to take a second, discuss with your partner, and based on the numbers that are given to you, I want you to think if you can come up with the word that should go in that blank. So what are we trying to solve for here? Okay, talk it over with your partner. All right, so let's see how we did. Well, we know that if we start at the right angle, the 90 degrees, that diagonal from that is the hypotenuse, or C. So C is not missing. We know we have one leg, so we're missing this other leg right here. So for our blank, hopefully you came up with a word that we are going to be solving for a leg, and that just means we're solving for A or B. So we're going to do this first one together, and then after that you'll have some time to practice when you're solving for A or B. So like in our previous problems, the Pythagorean Theorem formula is still the same. I want you to start by finding our 90-degree angle, which is at the bottom left. If we draw our arrow across, that tells us what side C is. So we know in this case side C is 26. We know that one of our legs is 10. Now again, it doesn't matter which letter A or B we put next to 10. But let's all do this the same here. We're going to put A next to 10, which means that B is missing. Okay, so as we go through this, again, we're just substituting things in where they go. So we know over here in our formula, where it says A squared, that we have 10 on the leg of the triangle where A is. So it's going to say 10 squared plus. Now in this one, it's a little different because B doesn't have a number yet. So our variable B is going to stay a variable. So 10 squared plus B squared, and again, that's because it's missing. And instead of saying equals C squared, it's going to equal 26 squared. Okay? So just like last time, we need to find out what these squares are. So you guys, again, are going to help me out. What's 10 squared give me? One more time, what's 10 squared? Okay, so we should have said 100. So I have 100 plus B squared, and that's going to equal 26 squared. And I'll help you out a little bit. 26 squared is going to leave us with 276. So now we have this equation, and think about when we've solved equations in the past, we want to isolate our variable. So we have B squared that we want to isolate. So we want that by itself. In order to do that, we're going to have to move our 100 over to the other side. Now think about inverse operations. If 100 is positive, you're going to help me out. What's the inverse of positive 100? So hopefully we said negative 100, so we're going to subtract 100 from both sides. Okay, so our 100s on the left cancel out, and we're left with B squared. And then we just have to subtract 276 minus 100, which is 176. So again, going back to our previous problems, in these Pythagorean Theorem questions, your last step is the inverse of squared. And we know the inverse of squared is square root. Everybody say square root. So to find our answer for B, we're going to need to square root 176. When we do that, we're going to round it to the tens place because that's what we've been practicing when we estimated. And that leaves us with 13 and 3/10 as our value for B. Now remember what we know about Pythagorean Theorem, what we've talked about? If you look over to the left, side C right here always has to be the longest side. So one quick way you can check your work is if I got my answer for B and it was longer than side C, I know I probably messed something up. But in our case, B was only 13 3/10, C was 26, so we know we are correct. Okay, let's go on to our next one. So on our next problem, I've labeled them for you. I want to give you a second here to work. I want you to work through this question. Then we're going to go through it, and then after that, you'll have some time to work on our last two. Okay, ready, go. All right, so let's go through this and let's check how we did. So the first thing we should have done was to substitute 12 and 15 in for A and C, and that leaves us with 12 squared plus B squared equals 15 squared. From there, we have to actually square our numbers. So 12 squared gave us 144. Remember, B squared is still B squared. 15 squared gave us 225. As we had to before, we need to move a number over to the other side of our equal sign to combine our constants. So we had to subtract 144 from both sides, which leaves us with B squared equals 81. Then our final step was to get rid of that squared by the inverse operation of squaring a number, which is square rooting a number. So you had to square root 81, and it should have left you with 9. Again, we can check our work. If 15 is greater than 9, we probably are correct, so we're going to be good to go. 9 should have been our answer. All right, so you've got two more practice problems. I'm going to give you time to work on these, and then we'll move on to the final section of our practice for today. Okay? Go ahead and begin. Okay, so hopefully you've had enough time to get through these two questions. Let's go ahead and check our work and just see how we did. So regardless of whether you solved for A or B, on the first question your answer should have come out as 8, a whole number. And then on the second question our answer should have been rounded to the tens place, which was 5 7/10. Now with that said, let's look at our very last section of today's notes. Okay guys, so we're ready for our last section, which is over word problems. You have 3 questions here. We're going to do the first one together. So as I read through it, wherever I stop, you guys got to say the next word. And remember, we need everybody following along. We are a team, and we all are going to say the next word. All right, here we go. So it says, John leaves to go. He walks 6 north and then blocks How far is from the... Okay, so we have this situation about John who walks home from school, and he walks 6 blocks north, 8 blocks west. We just have to figure out how far that distance actually is. So with these word problems, I want you to draw a diagram to start from. So they didn't give you the triangle on here. We have to draw it, so we're going to do that. So let's start with what it says first, which is that John leaves school to go home. So I'm going to draw school. So here's his school building, and I'm going to even label this CMA. So we got our school building right there that John is leaving from. So he walks 6 blocks north. Now, for those of us who don't know our directions, north is up, south is down, east is right, west is left. So we have our little compass over here to the left. So he's going to walk 6 blocks north. So from school, he's going to walk 6 blocks north. So we got 6 blocks north. Then he's going to turn and walk 8 blocks west. Okay. Now remember that he's walking a further distance west than he walked north. So our line is going to be a little bit longer than our other line. So we have 8 blocks that he walked north. Okay. So now our job that we're trying to figure out is what is this distance from his house to school. So I want you to take a second and talk with your table partner. If we're trying to figure out that red line on my screen, the distance from school to his home, if it was a straight line, what side of the triangle are we trying to find? So go ahead and talk about that with your partner. Go. So hopefully you notice that we have a 90-degree angle in this corner up here. And if we look at the side that's opposite our 90-degree angle like we've practiced, this means that that distance we're trying to find, or the diagonal longest side, is side C. So side C is missing in this problem. So as we set this up, remember the 8 blocks could be A or B. I'm going to label it A. The 6 blocks could be A or B, but since we've already used A, we're going to put B for 6 blocks. And then we just sub this back into the formula that we've been using. Remember, the formula for Pythagorean Theorem is a squared plus b squared equals c squared. And we're just going to plug it in and work from there. So now you're going to have a chance to finish this problem. So you're going to start by substituting in the 8 and the 6 in for A and B. Once you have finished that, there's a couple of practice problems down below. And anytime we do a word problem, I want you to draw out a sketch or a diagram of what the problem is saying. So for the one about the soccer field and about the TV, you're going to have a sketched diagram of what this looks like. Then you're going to solve it over to the side. Good job today, guys.